Okay, lesson on metallic bonding. This actually is in bold on your syllabus, as you can see here, and it's only 3 points, but it will occur in paper 2, not paper 1. And it is triple science content exclusively. So metallic bonding. First thing is, what is it and how do you spot it? So metallic bonding is the bonding in a metal. It is not the bonding between two metals. That's very incorrect. So metals do not form chemical bonds. They form alloys, which are mixtures, which is later on. For now, this is the bonding inside a metal, within a metal. Now, unlike the ionic and covalent bonding, which require dot-cross diagrams, this is actually much easier. You just need to know what the metallic bonding actually is. So it is an electrostatic attraction between positive ions, in other words, cations, and a sea of delocalized electrons. So you see all bondings are attractions. Ionic was between positive and negative ions. Metallic is between positive ions and delocalized electrons. That's the difference. Covalent bonding was between shared pair of electrons and atomic nuclei. So you need to make sure you know the 3 definitions of bonding and don't confuse the words. So if you look at a diagram, this is for a group 1 metal. The charge is +1 because the metal, say sodium 281, would lose its last electron in order to be left with 8 electrons and be more stable. So it loses an electron to form a +1 charge, and the electron goes on the outside of the ion. And that's what you see in this diagram here. If you were practically drawing this in an actual exam paper, I would draw plus circle, plus, another row underneath. Excuse, everything should be the same size. Then I would put a minus on each circle. And I would put a label that these are the delocalized electrons. And these are the metal. I like to call them metal cations because cations means positive ions. On the other hand, if you're doing a group 2 metal, remember you can go all the way up to group 3. If you're doing a group 2 metal such as magnesium, then what you want to do is put a 2+ charge. Obviously, ignore the fact that there's little gaps between them. They shouldn't because it's a solid. This is just a representation that we're doing. Each one will have 2 delocalized electrons, each one circle. And you get the pattern. If it's aluminium, which is 3+, it'll be 3+ with 3 minuses on each one. So these are the attractions. Delocalized means the electrons can move anywhere within the structure, which gives the metals a very key property that they can conduct electricity at all times. So solids, liquids, it doesn't matter. They will always conduct electricity. So unlike ionic bonding, where it had to be molten or aqueous, this will conduct electricity as a solid. And obviously in no other forms. The second property you need to know is the malleability, which means how easily you can be hammered into shape. Also, ductility, which means how easily you can be drawn into a wire, would be the same explanation. And the answer is that the layers of metal cations can slide over each other. That's the reason why the metals are malleable. So even though the attractions are strong between the delocalized electrons and the metal cations, the cations can actually slide over each other. And that's what makes the metals malleable. Now, later on, you'll do alloys and how those are hardened metals. But for now, this is the key point. And that brings to a close the bonding topic. There's only one thing we didn't mention is what structure metallic bonding forms. And the structure is called, surprise, surprise, a giant metallic lattice. So in conclusion, we had ionic bonding with a giant ionic lattice. We had covalent bonding with a giant covalent lattice for diamond and graphite, and then simple molecular structure. And for metallic bonding, we have a giant metallic lattice. So there's three types of giant structures: ionic, covalent, and metallic. I will provide you an overview lesson of all the different structures and bondings on one sheet of paper so you can see them in the next lesson, and that will draw to a close the bonding topic.